So no, these are all good questions. So you're not judged on, does your SLP work at the end or not, okay? Depending on what you're trying to do, it may be most likely that your SLP is not going to work. You may be trying to do something very experimental, and it may not come out the way that you were hoping at the end. That's okay. The real metric for the SLP is, are you making progress in your plan of attack? Are you meeting your milestones? Are you adjusting your milestones as necessary? Are you learning along the way? Right? Are you expanding your knowledge? If you decide I'm going to do X and you get halfway through and you realize X was too ambitious, and so you adjust and you decide you're going to do Y instead, right? That's a valuable experience. That's a big part of what you want to get out of this is being able to manage a large-scale project, self-manage, set milestones, monitor progress, things like that. If you get something out at the end that's fun to show and tell, that's bonus, right? If it's something you can turn into a business, that's extra bonus. If it's something that works but it's not polished, that's absolutely fine, right? That's a prototype. If it's something that's well documented but it doesn't work the way that you wanted it to, that's fine too. If we say this must work correctly or you're going to fail, right, then nobody's going to take a chance. Everyone's going to do something that they're positive they can do, and you don't really change the world by doing things that you know how to do already. So I want you to be able to take a chance and stretch yourself and, shoot high and see where you end up. So yeah, don't stress too much about that. But this is part of why we're setting milestones along the way, and be checking in with your milestones. And if you realize you're going to get nowhere near your milestone, right, as soon as you realize that, you'd like to make some adjustments. And if it changes the scope of the project, you want to talk to me about it and say, hey, I'm scaling back, or I'm redirecting, or something like that, so that there's no surprises at the end.
What if you pivot completely?
If you pivot like now completely, that's not a problem at all.
Yeah.
If you pivot the week before June presentation, that's a big problem.
Like halfway through?
Halfway through. Depends how big a pivot. So typically at the end of fall quarter, you've explored whatever it is you're proposing. That's not a bad time to say, this was not what I wanted to do, and to pivot, but you would have to work really hard in the beginning of winter quarter to sort of make up for not having done any work on this new project in fall. Once you're pretty far into winter quarter, it's getting kind of late to change gears, because it's something you should be working on for 3 quarters. So you want to keep that in mind while you're going through this quarter and fall, trying to sort of pin down what you want to do. And you want to be thinking realistically, like, what am I going to be doing on this in January? What am I going to be doing on this in March? What am I going to be doing on this in June? And if it just fills you with dread to think of this going on that long, right, maybe you want to modify your idea and find something that, would be a little more joyous to be working on all that time. It's not an exact science coming up with these things, to say the least. All right, other questions?
So when do we have to have our idea essentially by?
Check Canvas. I think it's this Friday.
Yeah.
It's version 1.
But that's just a rough draft. You can change that for like.
You can tweak it, yeah. We're going to modulate it. I'm going to look it over and I'll give you some feedback. You can either say this is perfect, go forward, or say, can you fill in some more detail here? Can you further explain that, or so on and so forth? And we'll go back and forth a few times as necessary. All right, so I want to talk about the latest ODP. We're back to writing ODPs in C. So I'm going to talk about this one, and this is going to involve some error checking. So I'm going to talk about argc and argv, everybody's favorite variables. And then I want to talk a little bit about processing input and parsing input, and scanf and things like that. And then I want to talk a little bit about options for using Linux and customizing your environment and being more efficient in Linux. So we'll go through that. And then tomorrow I want to talk about VI. And even though VI is this big thing, I want to give you a small kernel of things in VI that might be useful. Because you can use VI like you use Notepad. You can move around with the arrow keys and you can type, right? And you can backspace to delete. But there's so much more you can do that's way more efficient. And so I want to go through that tomorrow. All right, so here's ODP 409. 408, which you already did, you wrote a C program that basically you run it with a command line argument, which is a number, and it prints out the square root of the number. And for 408, I said you can assume the number is present, it's a double, and it's not negative. So all you had to do was take that number, convert it, and then print out the square root. So 409, we're throwing in error checking. And there's three possible sources of error when you run this program. You're supposed to run this with a command line argument, which is a number. So you're supposed to say something like I called my ODP S1. You're supposed to say S1 space and put in a number, and it prints out the square root. So if you do that, it's just like ODP 408. But there's three ways this can go wrong. One, you may not give it exactly one number. It may be that you run this without a command line argument. Or it may be that you run this with more than one command line argument. Both of those are error conditions. And in either case, you want to print out ERR and exit. So that's the first thing to check. Make sure you have exactly one command line argument. Any more, any fewer, print out ERR and exit. Okay, if you have exactly one command line argument, it may be that it's not a valid number. It may be something like haha. In that case, print out the word INV for invalid and exit. Don't do anything else. If you have exactly one command line argument, and if it is a valid double precision number, it still could be negative. In that case, print out NEG negative and exit. So you got three things you got to check. Exactly one command line argument, which is a valid double precision number and is not negative. If all three of those are true, then go ahead and print out its square root. Does that make sense? So let's flowchart this.
I don't know his name, but
So first thing you want to do is see if you have exactly one argument. Thanks. If you came in late after this went around, just sign in at the end of class. See if you have exactly one argument. If you don't, print out error and exit. If you have exactly one argument, is it a valid double? If not, print out invalid, and you're done. If it is a double, is it greater than or equal to 0? If not, print out negative, and you're done. If it is, print the square root of the argument and return. So there's actually no looping here. It's really just a big if statement.
Is it not multiple if statements?
It's multiple if statements.
Cool.
right? There's no input from the user here. That when the program is running, it doesn't say enter a number and you type in a number. It's just a command line argument. Right? If you run it without an argument, it doesn't have exactly one argument, print out ERR and return or exit. So this is a fairly simple flowchart, but having something like this will help you when you're writing your code catch some common errors. For example, a lot of people will check to see whether or not the argument is a valid double before they've checked to see if they have exactly one argument. And you end up getting seg faults. Right? If you run this without a command line argument and you try to use scanf to see if argv bracket 1 is a double, you're going to seg fault. The way to avoid that is before you check that argument to see if it's double, see if the argument exists, see if you have exactly one argument.
So what is a seg fault? Is that when you try and access something that isn't there?
Basically, yeah. We'll get some seg faults going in a little bit. All right, so everybody clear on the desired behavior? Right, run it with a command line argument, print out the square root, and there's 3 error conditions possible. And test the heck out of this before you assess it. Write a main program and pass different things as a command line argument. Run it with no command line arguments, run it with 3 command line arguments, run it with an argument that's not an integer, run it with a negative argument. Run it with a negative argument followed by something that's not an integer. Try 15, 20 different approaches to this and make sure it always does exactly the right thing. When all of that works, go ahead and run it through the assess system. Make sure you get 10 out of 10 on each test. All right, any questions on that? So how do we deal with command line arguments? So here's our prototype main program in C. Include standard I/O if you're going to do any input/output. We're going to do some printfs. And then our main program has 2 arguments that it takes, argc and argv. Argc is an int, argv is a char star star, whatever that is. Okay, let's just play with argc first. And the deal is, if I compile this and I call the executable go, and then on my command line in Linux I say go space, and I type something in after the word go, that thing I type is a command line argument. Okay. Technically, the name of the program itself, go, is also a command line argument. So bash will say, hey, you've typed in 2 things. You typed in the word go, which is a program name, and then you typed in, I don't know, the number 25. Okay. 2 things. It's going to call main, and that first argument is going to be the number 2. Okay, so the shell is basically calling this function, which is a main program, but it's this function called main, and the first argument will be the number of things I typed on the command line. So argc will always be the number of arguments that you have. So let's just print out the value of argc. So if I just say go, argc is 1. Why? Because I typed 1 thing on the command line, just the word go. If I say go, go, argc is 2, because there's 2 things on there. If I say go 246, argc is 4, because there's 4 things on there. So a thing is stuff separated by a white space. Alright, so there argc is also 4.
Is there a way to start the count, not including go?
Subtract 1. That'll always work, because it always counts that one. And if I do this, go quote 246, argc is 2. Because to the shell, things that are enclosed in quotation marks are like a single thing. Alright, so that's actually just 4. Go, 1, 2, 3, 4, 5, and 6. 4 things total. Four arguments. Each of them happens to be an empty string, but it's still 4 arguments. Okay, so it's a very kind of literal interpretation of this. Just how much stuff do you see on there separated by spaces? All right, so the beginning of this, do we have exactly one argument, is really simple. Check to see if argc is equal to 2. If argc is not equal to 2, print out error and return. Otherwise, we can go ahead and we can go on to our next check, which is there is at least one, there's exactly one argument. Is it a valid double? Okay, so we got to figure out how to tell what our argument is. So integer I says I is an integer, right? Pretty straightforward. What does integer star I say that I is?
A pointer to an integer.
It's a pointer to an integer. Which is also an array of ints. Because arrays and pointers somehow are linked together in C. If you say character star C, C is a pointer to a car, but C is an array of cars. So if I say car star star argv, if we just kind of extrapolate from these first 2 examples, this means argv is a pointer to a car star. Right? Car star argv would say argv is a car star. Car star star argv says argv is a pointer to this type, which is a car star. An array of characters is also called a string. So argv is an array of car star. Argv is actually an array of strings. And that's how we want to think of argv. It's an array, one string, another string, another string, another string. So argv bracket 0 is some string. Argv bracket 1 is some other string. And so on. And you have exactly argc of these. And this first string is going to be the name of your program. The second string is going to be the first command line argument. The next string will be the next command line argument, and so on. So the elements of this array of strings are the things that you put on the command line when you ran your program. And you have argc of them. So let's take a look at them. So let's just write a for loop. I goes from 0 to argc minus 1, and let's print out the string argv bracket, and we'll print %d to show the value of I, and then we'll print out the value of argv bracket I as a string %s. So let's see what these arguments are.
I think it needs a double quote too.
It sure does. Thank you. So let's see what this looks like. So if I just say go, argc is 1 and argv bracket 0 is go.
Can you show the code again?
I will in a sec. If I say go, this is a test, argc is 5, and the first 5 elements of the argv array are exactly what I typed on the command line. If I say go 25, argc is 2, and the arguments of the array are go and 25. Okay, this is all there is to argc and argv. argv is an array of strings, which are the things you put on the command line, and argc tells you how many strings are in that array. And if argc is 1, you have exactly 1 string on the command line. You're allowed to use argv bracket 0, but that's it. Don't use argv bracket 1, bracket 2, bracket 5, bracket 10. They're technically invalid. If argc is equal to 5, you've got exactly 5 strings, argv 0, 1, 2, 3, and 4. So you can use those first 5 elements of the array. Don't try to use any other elements of the array. You risk a seg fault. Right, and argv is not magic. We could call it ha 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 if we want. And we could call argc ho ho ho. And this will work perfectly fine, right? They're just variables. But in almost any planet in the galaxy, maybe, you want to call it argc and argv. Okay, if you're writing code for somebody else or a job interview, don't call it ha ha and ho ho. Unless maybe it's Google. So argc and argv is just what we call them. But they're just variables declaring a function. They're kind of placeholders.
Like how for loops you should use I.
Yeah, for the outer loop. J for the inner. All right, so does that make sense?
What should you use for the third loop?
I would guess K. But I'm sure Stack Overflow would have a different answer. Real programmers don't write 3 nested loops. Find a better way to do it. Loser. Or something like that. All right, so this is it. It's mysterious and confusing, but that optional text that I posted a link to on Canvas, the one that I wrote, has a whole section on argc, argv that basically spells all this out and goes through some examples. So if you want another exposition of it, you can look there also, because this is perennially confusing to people, but it's really just an array of strings. Now, if we decide to be a rebel and look beyond element argc minus 1, so let's just loop through the first 100 or so elements of the argv array. There is stuff in there, and we eventually get a seg fault. But you know, I said go, this is fun, so this was go, this is fun. The next element was null. Okay, that's the one that'll usually get you into trouble. But if I look beyond that anyway, I see this string that says equals less close equals user bin less pipe %s %s. I don't know what that means. Display, this is telling me something about where I'm outputting. This is a unique ID to my session. How my color settings are set up. There's my username. That's kind of useful to be able to find. So something about SSH authorization and my user ID and my home directory and the directory I'm currently sitting in. There's lots of information here.
And if you reran it, it would all be different.
I think it'll be the same in this case, but if I run it from a different directory, or if you run this, it'll come out different. This is not actually random. This is what we call the environment setup. And it's provided to the program along with your command line arguments. Today on this system, if you do this on a different machine, different environment, you may not see this. So we don't want to rely on this stuff, but you know, there's stuff out there.
There's 57.
There's the name of my laptop on my local network. So buffer overruns can be fun, right? And then 57 was null, and then when I tried to use element 58, so the 59th element of this array, I actually got a seg fault. It wasn't available in memory. But in general, we want to make sure we only, if we have argc, we only check element 0 through argc minus 1. Like that. All right, so that's the argc argv business. So if we want to, if we check, we've got exactly one argument, we want to convert it to a double. What is that argument that we should be checking to see if it's a valid double? It's argv bracket 1. All right, and we want to know if that's a double, and if it is, we want to take its square root. Well, we can't just square root argv bracket 1. These are strings, right? The square root function expects a double. If I try to call it with argv bracket 1, I'll get a compile error. It won't even get to running. So we've got to do two things. We've got to know if argv bracket 1 looks like a valid double. Does it contain a digit and maybe a decimal point and maybe some more digits and so on? And then we need to turn it into an actual number so we can see if it's bigger than 0, and we can pass it to the square root function. And there's a single function that will do both of those things for us. And this is going to be your favorite function for a while. That's called scanf. And scanf typically takes 3 or more arguments. So it takes a string, an array of characters, and then it takes a list of formatting, which is also a string, and then it takes 1 or more output vars. And so a typical usage might be something like scanf. Well, what do we want to convert? argv bracket 1. And what do we want to convert it as? We want to see if it's a double precision number. And the instructions from OTP 408 said use %lf. And then our output variable will just specify the address of some number, where previously we said that's a double. So this was the heart of your previous ODP. But that was simplified. We assumed the user was using the code correctly. So let's get rid of this. Alright, so first thing you're going to want to do is check to make sure you've got one command line argument, meaning argc is equal to 2. And I'm just going to assume this is the case. And let's go ahead and call scanf, convert argv bracket 1 using lf into num, and then let's print out the value of num. And we'll print it as a %lf. That's a double. So if I say go 25, my number is 25. That works great. If you don't do this check in the beginning to make sure you have a command line argument, if you just say go, you get your seg fault. Because argv bracket 1 is not something we're supposed to use, because if without any arguments argc is 1, you've only got one thing in your argv array, that's argv bracket 0. If you try to use argv bracket 1, you're not playing by the rules. In this case, we got a seg fault. But as long as this is a valid double precision number, I can use scanf and convert it correctly. The problem is, if this is not a valid double precision number, it turns out num just equals 0. But if this is the number 0, it turns out num equals 0 in that case too. So I can't just check to see if number is equal to 0 to know if your input was valid or not. We need to have some way of knowing, did scanf find a double precision number or not?
The return value.
And we can use the return value from scanf. So if you do a manual page on scanf and come down to where it says return value, it says on success these functions return the number of input items successfully matched and assigned. Okay, matched and assigned, meaning it's going to start processing the string, it's going to look for a double, and if it finds it, it will take the value and assign it to this variable. Since I'm only asking it to match and assign one thing, and if it succeeds, the return value from scanf should be 1. If it's not 1, then something went wrong. So let's save the return value in a variable called return value.
Now, will that also set the number?
At num?
Yeah.
Yes, if it succeeds. So return value has a very specific meaning, right? It's not just a value that's being returned by the function. For example, scanf is in some sense returning a value for this variable, but that's not what we mean. When we say return value, we really mean the value of this function. If you say variable equals function, what does that variable get set equal to? And if you're writing a function, it's the value you put when you say return some number or expression. That's the return value. So let's take the return value from this and let's print it out. And it's just going to be an integer. Up there, so it's an integer, scanf. So we'll save that and we'll print it out with some typos. So if I say go 25, the return value from scanf is 1. It found a double and it converted it. That's what we want. If I say go ha ha ha, return value from scanf is 0. It found 0 things to convert and store. Okay. This tells me I did not have a valid double. So I'm going to print out invalid and I'm going to exit. And it may not be 0 if something goes wrong. Here I did not have a valid argument, but it actually returned -1. It's a flag saying that the thing I was trying to scan was empty. So here's how you check to see if you succeeded in doing your scanf. If you're trying to save one thing, did scanf return 1? Or did it return something different from 1? Don't check for 0 as an error, because it could be 0, it could be -1.
Equal or greater than 0.
Equal to 1,
Okay.
or not equal to 1 is the safest way. If you're trying to convert 3 things, did it return a 3 or did it return something not equal to 3? Because it could return 2, could return 1, 0, -1, right? So equal to 3 is success, not equal to 3, something went wrong. Alright, and if it returns exactly 1, then in that case we know that the value of this variable num has been updated to match the value that appeared in this string, argv bracket 1. So check scanf's return value. If it was not equal to 1, invalid. Otherwise, num now has a value. Check to see if it's bigger than or equal to 0. So if num is less than 0, print out negative and return. Otherwise, print the square root of num and then return. So it's really ODP 408, but you're adding all these extra checks in the beginning. So write your ODP, test the heck out of it. Okay. I'm really happy that the network has been pretty stable this year. It's like way better than it's been in the past. I mean, I can just come here and I'm still connected.
Don't jinx it, Nick.
That's so nice. I have faith.
Is it
All right.
because of the new tower?
No, that's just Verizon, and it's only outside the building as far as I know. Well, maybe. I don't know. I mean, purple Sasquatch is everywhere. So run your ODP, right? Give it a valid double precision number. It should just print out the square root. Run it with no arguments. It should say error. Run it with more than one argument. It should say error. Whatever those arguments are, right? Run it with something that's not a valid double precision number. It should say invalid.
Okay.
Right? All of those cases, they have one argument, so it's not an error, but it's not a double precision number, print out invalid. And then try some negative numbers. It should say negative, and then try something that's not negative, and it should show you the square root, and so on. So test all these cases, right? Yeah, I mean, just exercise them. Hand your executable to a friend and say, try and break this, right? And then when you're pretty sure it works, go ahead and run it through assess. All right, you should get 10 out of 10 on everything. Make sense? All right, so we'll talk more another day about scanf and scanf and why I want you to use scanf instead of scanf. We'll talk about how to detect things like if you're supposed to put in an integer but you type in something like 3.2, how can we detect that that's not an integer? Because scanf will parse that and say it's an int. So we'll discuss how to deal with that, and some other details like that. I want to talk a little about Linux access and customizing Linux and being a little more efficient in Linux and things like that. And tomorrow I want to talk about VI extensively, as well as the next ODP. We'll mainly talk about VI tomorrow. So any other questions on the ODP or scanf or things like that? Mess around with it, write lots of code, try to break it, right? Find the weird corners. All right, so we've talked about command line recall. You can hit an up arrow and get back to previous commands, right? And if you set up your history, you can get, in my case, thousands of previous commands. And you can go up and you can go down and you can go back with a left arrow and forward with a right arrow. You can go Control A to get to the first character, Control E to get to the end of your line. And you can also do Control arrow to go back by words. And so if you have some long command that you typed in, I don't seem to type long commands. You can move around it more quickly like that. There's some long commands. So that's a quick way to do things. All right, you tried to compile and you typed in the wrong name, GDD instead of GCC. So one option is to go up and come back to the beginning and go forward and edit that. Here's another option, GCC exclamation asterisk. So exclamation asterisk recalls all but the first word from your previous line. And so that will bring back the -o go.c. Exclamation exclamation will pull back the entire previous line. It's just like hitting an up arrow. Exclamation dollar will pull back the last word from your previous line. And these aren't necessarily lifesavers, but throw them on a post-it note somewhere, and once in a while you'll find an occasion to use them. And if they turn out to be really useful for you, you'll use them enough that you'll remember them. I end up using these all the time. Maybe it's because I make lots of typos. But, you know, I type in some command and I put in the wrong last word. So most Unix commands, the last thing on the command line is the output. Right? It's the thing that you're trying to write into or modify or change. And a lot of times I want to do the same thing to different files, and so I just want to, like, repeat the previous command with a different last name. Or I want to do something different to the last piece of a file. I want to compile it, and then I want to execute it, and then I want to edit it. And I can use exclamation dollars. You just keep pulling off that last piece. So those are useful to throw in your bag of tricks. Have we talked about tab completion? Okay. So let's see. So I've got my main file, which is called, this is my main file, and I want to edit this. I can say vi, this is my main file. And I'm going to make typos when I try to do that, right? So if I say vi space th and I hit a tab, it'll fill in the rest of my file name for me. Okay, it's an autocomplete option. In fact, if I just said T and hit a tab, it would fill in the rest of my file name for me. And if I want to compile that, I can say gcc-o, and I can just type th and hit a tab. Well, I don't want to call my output.c, so I'll just correct that, and then I'll just autocomplete the name of the file. Right? And I got this by typing like 5 keystrokes instead of a gazillion.
And then since you have one that without a C and just a .c, you can tab twice and it'll show you the middle.
Although if I try to run this, if I say this, yeah, if I say this, it'll complete to the one that's executable. But let's say I want to edit this, so I'll say ls-l thi and I hit a tab. It takes me as far as it can without ambiguity. I might be trying to use this as my main file, or this is my main file.c. If I hit tab twice, it'll show me all my options. And then I could say, oh yeah, I want the one that's .c. So it gives me a quick backup, and you can kind of go from there. All right, so command line completion is useful. If I'm sitting here at the command prompt and I just hit a tab, I haven't typed anything yet. If I hit tab twice, I don't have it set up. If I just hit tab twice, it says you want to see all 1,546 possibilities. There's 1,500 things that I might have legitimately been typing here that started with nothing. In other words, there's 1,500 commands that I could type at this point. If I say yes, it'll show them all to me, one page at a time. So colon is a command, exclamation mark is a command, bracket is a command, double bracket is a command, along with 2 to 3 and my ODP and all this stuff. And when you see more, you hit a space to move down to the next page, and I can look at all of these one page at a time. And I can hit a Q to quit out of more. Or if I want to know all the commands that start with a G, I can just type a G and hit 2 tabs. There's 112 commands that start with a G. So there's GCC, but there's also all these other ones. So you can also use it to look around. I keep using Control U. If you want to get rid of everything you've typed, Control U clears out the whole line. If you want to see everything you've typed, Control R repeats it. Oh, but I got Emacs stuff going. Forget Control R. Control U clears out the line. It's a little more gentle than Control C. Yeah?
What does Control Z do when you're in Vi?
It suspends your process. most likely. Right, so it stops it, but it's still sitting out there running. And if I log out, then when I try to log in again, I'll get that swap error file. If I want to go back after Control Z, you can say FG for foreground, and you come back in.
What?
So if you do Control Z on a command, it says stopped, and I'm back here at my shell. If I want to get back to where I was, just say FG, and it brings you back to where you were when you said Control Z. We're going to talk a lot about this another day, because this is related to processes on Unix.
Okay. Just go to Control Z a lot, and then I ruin everything.
Yeah, so you can undo it with an FG,
Gotcha.
or just stop doing that.
Well,
Like put a thumbtack on the Z pin or something. So nice using Chromebooks, they don't have cap locks on them. It's like, how many decades did it take people to like admit that we don't really use cap locks much?
I use cap.
Do you?
Yeah.
Really? You shout at people, or?
I mean,
Because most of the
sometimes-
commands in Unix are lowercase.
Yeah, but like when you're doing the ODP stuff,
Yeah.
ODP is like capitalized. So you just cap locks that, and then you.
Oh wow, you have to hold shift for a couple of seconds.
Well, no, but like it.
That's interesting.
Yeah.
So it is more useful than I thought.
Yeah.
I
Okay.
don't capitalize the ODPs.
Yeah. Okay, interesting.
We could have an entire debate on this.
Well, yeah, we could, totally. We should take it on Stack Overflow, though.
Oh, no.
How are we supposed to write angry comments without caps lock?
Well, that's the main thing, is we want to shout at people, right? So that's always good. All right, so I'll talk about PuTTY really briefly tomorrow. I just want to make sure people realize that in PuTTY you can set up customization of your environment, and you can save that, so when you start running PuTTY, it automatically loads in your username, the name of the server, and your default font size and background color and all that sort of stuff.
Okay.
So I'll talk about that, and then we'll mostly talk about VI tomorrow.
I have another question. If I go to log out on the Unix server, and I get this message saying 0 jobs.
Yeah, it means you Control Z to something. So say jobs.
Press F3.
If you say jobs, it'll show you what your
I mean
jobs are.
FG. Type in
Then I
FG.
hit FG.
And then you can FG to each one, yeah.